So again, welcome to the webinar. This morning our topic is simulation and visualization for SolidWorks users in Fusion 360. So the topics we're going to be covering are visualization and simulation. There are several other things we can do inside of Fusion 360. But for the SolidWorks users, we picked a couple of quick topics that might interest you. You may have heard of Fusion 360 and wonder what its capabilities are and how it could help you out. And so hopefully this webinar today will answer some of those questions. Okay, so I'm in the rendering environment in Fusion 360 right here. And let me just jump back to the regular modeling environment. Fusion 360 is a full modeling package. We have parametrics, we have direct editing, we have freeform. So while you can model and create things inside of Fusion 360, if you're on this webinar, you're probably already using SolidWorks for that design. And SolidWorks is a great tool for that. You have processes, you have design history, you have reasons to keep using SolidWorks for your designs. What we're going to be taking a look at this morning is how can Fusion help with some of these extra workflows that happen after the modeling is done. And in fact, you'll even see in some of our examples when we get into the simulation, we'll be doing a little bit of direct editing inside of Fusion. We'll be looking at how that can help the simulation process. We'll also be taking a look at a process that uses SolidWorks for the modeling changes. So what I'm going to do here is just jump into my data panel. This is where all the data is stored inside of Fusion 360, all on the cloud. So I could log into any computer and get access to all these projects. And here we see a few of the topics that we're going to be hitting. Inside of the simulation, we have some Fusion designs. We have some SolidWorks designs, in fact, directly linked. So we'll be taking a look at the connecting rod. We'll be doing some static stress analysis. We'll be doing some thermal analysis on this radiator assembly. After we're done with that, we're going to jump to visualization and open up a few fun models inside of Fusion to see what kind of capabilities it can give us on that front. Okay. So before I even jump into this simulation example, I want to talk about getting your SolidWorks data into Fusion 360. They're actually a pretty easy process to get your data in here, and there are a couple different ways we can do it. The easiest way is right inside of Fusion 360, we can click the Upload button. And we can select files or drag and drop. And so here I have a few SolidWorks files that I modeled. And what I'm going to do is just drag one of them, drop it straight into the Fusion interface, and click the Upload button. And I can close this dialog box. Any processing, uploading is going to happen in the background, and this file will become available to me once it's done. So you'll notice the icon here. This file actually came in as a Fusion design rather than a SolidWorks design, but I do have some SolidWorks designs down here. Fusion 360, because it's cloud-based, it does have a web interface that you can use to access files as well. And so if we were to upload a SolidWorks file in the web interface, it'll actually upload the SolidWorks file natively without converting it to Fusion. This is a really quick, easy way to add your designs into, get the capabilities to view and collaborate on them. We're not going to really be going into the collaboration part in our webinar this morning just for the sake of time. But as you can see, even though this is not a Fusion design, I can get the full access to review the file. We have commenting and markup tools that allow us to, collaborate with the rest of our team on that design. Now, what we're going to be doing today, we'll actually be working inside of Fusion. So this design is just converted automatically to a Fusion design. And if I double-click now, it will open the design inside of Fusion. So this was a SolidWorks file just a second ago. Now it's been uploaded to my cloud database, and I have full access to do anything I need to in Fusion with this file. Another way you can do the same transition, if you've already uploaded a SolidWorks file for collaboration purposes on Fusion Team, you can right-click a SolidWorks file right here in your Fusion data panel and just create a Fusion design. And that'll generate a design here that we can run some simulation on. I might add, in the near future, we will be able to run simulations on this SolidWorks file directly as a reference without having to convert it to a Fusion design. So, that'll make it even a little bit easier to clean up, without having multiple files in there. And of course, Fusion is changing all the time. It's got a major release just about every 6 weeks, and so we probably, who knows when we'll see that, but it should be coming out, I would think, later this year to be able to work directly on these SolidWorks files. All right, just a little bit of background on getting your designs into Fusion to be able to work with them. Now let's look at the cool stuff, actually getting into some of this simulation and some of this visualization. So the first thing I'm going to do is, in this connecting rod file, I'm going to switch to the simulation environment. And once I activate that workspace, I see my studies, I see my tools change to simulation tools, so we're not going to be at first modeling in this. What we want to do is set up a new simulation study. And so here are our simulation types. We have static, modal, thermal, and thermal stress studies. We have structural buckling, nonlinear static stress, event simulation, and shape optimization for lightweighting parts. Anyways, you can activate or you can access any of these inside of Fusion. Some of them are available in the basic version of Fusion, and some of them are available in the ultimate version of Fusion. So I'm just going to run a regular static stress here. And this will be a pretty simple study. If you're not a simulation expert, don't worry. We're just going to do some basic loads and constraints. This could be used kind of as a design tool. Maybe you're not running a final analysis that'll be stamped or anything like that, but you just want to run a quick test and see how close your design is or what quick changes might help your design out. And so we're going to go through, and first thing we're going to do is assign some materials. So for the 2 pins on this design, I want to pick a steel, and let's use our 107. And then for the connecting portion of the body, I'm going to pick the aluminum 5052. Obviously, different materials, different material properties, different results for the study. The next thing I'm going to do is just set up a simple study. Now I could do this much differently. I could make it much more complex and maybe get a little bit more accurate results. But I'm just going to do, for demonstration, a pretty quick, simple, what a designer might do inside of Fusion 360. So I'd like some force on this bar, but I don't want it pushing down into the material. I want to change the direction. We have a lot of options for what direction we want to go. We'll just slide this around, and it'll snap there to 90 degrees. And let's put 2,000 pounds. There you go. All right. So far, so good. The next thing I want to do is just take a look at the mesh real quick. Our mesh is going to be calculated. There are a lot of options for how fine you want the mesh. If you're familiar with FEA analysis, this looks familiar to you. I'm good with that for now, and we'll go ahead and click Solve. So here's one of the coolest things about Fusion 360's simulation tools. We have the ability to run them locally on our machine or send them to the cloud and let Autodesk servers process them. This is pretty awesome. If my study takes 10 minutes locally, I could send it to the cloud instead of my computer being locked out while it's calculating for 10 minutes. I could send it to the cloud and have the servers process it for me, possibly in less time than it would take on my local machine. and then send the results back to me when I'm done. So I could run a study, I could make some design changes, run another study, maybe change some materials, run a third study. The ability to run parallel studies on the cloud is one of the best parts of Fusion's simulation tools, I think. So I'm going to go ahead and solve this on the cloud, and we'll see what happens. It's preparing the solve. The file is going to save in the background. It's now going to be uploading to the cloud, sending to the servers to solve. And in fact, I could sit here and watch the progress, but I don't really want to do that. I'm going to go ahead and close it. Now I'm going to activate study 1. This was a similar design configuration. And what I found out was that the safety factor, if we get down, there's a few parts of the model where we can really see critical areas where that safety factor is pretty low. In fact, if I drag this up to here, all of those areas have a safety factor below 2. So I think definitely these arms here need to be thickened a little bit. While this is solving in the cloud, I'm going to go ahead back to the modeling environment. So this is one scenario where you maybe upload a SolidWorks design, and instead of going back to SolidWorks to make a modeling change, back to Fusion to simulate, back to SolidWorks to make another change, back to Fusion to simulate again, we're going to actually just make a quick change in Fusion 360. So all I'm going to do in the modeling environment here is let's do a press pull on a couple of these faces, and we'll add some thickness, about 3 millimeters there, and a press pull also on the inside of this. I want to shrink the size of that slot. So that we have a little more thickness in there. Now maybe I run through 3 or 4 of these, and whatever the final version is that I like, I send this back to the SolidWorks guys and say, hey, you know, I think this is the best scenario. Can we make these model changes? And it looks like something failed on that study. But that's why I have this study 1 up here. This is basically kind of the results that we were going to see. All right, let's activate this and remesh. So since the model changed, the mesh needs to be regenerated. And without having to even reset up anything else in the study, my loads are still there, my constraints are still there, the material is still assigned. I can just click solve and solve another one. Or if I want to keep the results as I've done here, I could right click and clone that study. And now I have a duplicate study with, you know, possibly different load settings or different materials. I do not have to reset it up. I'll just click the solve, and it would go ahead and solve it. So let's give that one more chance. All right, looks like it is scheduling that one. Okay, so I'm going to pull open these thermal studies. These are interesting too, and the idea with these, I just want to show a different take on the process. In the last case, we actually made some modifications to the model inside of Fusion for a quick secondary study, but that might not always be possible. You may be required or need to make your changes in SolidWorks. In this case, we probably have the same part file referenced multiple times inside of SolidWorks. And so if I could just open this file after my results and make a few quick modifications in the whole assembly update, that may be quicker and easier than updating it inside of Fusion. And so in this case, we'll take a look at the thermal simulation I did here. And what I noticed was that these radiators are not really doing their job too great. First of all, it's really hot towards the outside. We have this huge cool area in the middle that's really unnecessary. If we go to the heat flux, you have a large dark area there. So this material is really not even transferring much of the heat, whereas we have a lot more heat flux out towards the edges. And so in this case, maybe we send some results back to our guys in SolidWorks, and they rebuild it for us and let us run a secondary simulation. So without going through all the setup here and recreating it, we basically have an applied temperature on the inside of the pipes, hot water running through them. We have some convection between the pipes and the plates, and we have radiation, which allows heat to radiate off the plates. And in this case, let me go to this more accurate study. The results are a lot more even on the heat flux here. So we cut out some of that material, we expanded towards the outside, and if we probe a couple of these areas, we're going to get a lot more consistent results across our radiator. So there's really a ton of stuff you can do even beyond that in the simulation inside of Fusion 360. You guys saw the list of studies that are possible. It's really a great simulation tool, very powerful processors, and the ability to run multiple studies in parallel and then come back and continue working or work on other designs. It's pretty awesome inside of Fusion 360. Okay, so that is what I kind of wanted to show on the simulation. As I said before, if anybody has any questions at the very end of the presentation, we'll have some Q&A time. About 11:20, I want to move on to the rendering portion a little bit. So I'm going to go to the visualization, and as I started out, you guys saw the D3 logo here, and it was just in the rendering environment. Of course, we have the standard modeling type environment, but we can actually activate an in-canvas render, and that's where I started out today. What I'm going to do is open another assembly here. Just a little tricopter drone body. What I want to show you over the next few minutes is how easy it is to create pretty awesome looking renderings inside of Fusion, even if you're not a visualization expert. So here's my model, and again, I am in the modeling environment right now, but I want to look at rendering inside of Fusion 360. So let's switch to the rendering environment. Okay, I do want to close some of these other tabs. I think I get a lot of stuff open. Free up some memory for this thing. Yep, okay. So let me jump into another model. So a lot of 3D textures and things on that one. Okay, so this is a model. This was not created in Fusion. This was basically imported, dropped into Fusion. The first thing you usually want to do is set up your scene. The scene controls the lighting, the shadows. So if I just drag and drop, I can actually completely change the environment that this thing is rendered in. And you'll kind of see here on the highlights, we can definitely see sky now, and we can see that darker reddish surrounding horizon. If I drop this into the lake bed environment, much darker blue sky with a lighter background. So obviously your materials are going to look different in different environments, so this is the first step. But pretty easy to do. It's basically just drag and drop. You can definitely create your own custom environments as well. All right, so that's my first step, is just to drop a new environment in. To me, one of the coolest parts about Fusion 360's rendering environment is this material library they have. Even if you know nothing about material creation in a rendering tool, there is a huge library of materials available, and these keep getting updated. Every new update for Fusion, which as I mentioned is every 6 weeks or so, we get even more materials added. and even some pretty complex ones. So to use the new material, all we have to do is drag the material and drop it straight onto our model. And of course, this is kind of like a preview, but to get the full rendered effect, I can very easily click on the in-canvas renderer to get a live inside of my graphics preview of that material. So now we're getting the full rendering. We have even like reflections down here. It will take a while for this to resolve, and obviously it's rendering right now, so it takes a lot of calculation on there, but you'll really get the full effect of what your final rendered image will look like with that preview. So very easy to use. We even have, textures look really good inside of Fusion 360. The last model that I had pulled up with these 3D wood textures, those textures work more easily than I've ever seen in rendering program, and I've done a lot of it. So let me just pick one of those and drop it on here real quick. And what you'll see is it's basically like a 3D texture. We do have the ability to modify that texture, but it really looks like this thing was cut out of a chunk of wood. So what I'll do is texture map controls, and this is a 3D texture. So if I want to move the texture, you can just drag this, you can rotate it. So very easy to get pretty good, quick results. On the same line as what we had in the simulation environment, when I go to create my final rendered images, I have a couple of options. So a lot of preset sizes, but I have the ability to do a local or a cloud render. So not only can I use my local machine to render, but I can cloud render, depending on the size of the image, just a few credits. I can have Autodesk servers process that image for me. And when I'm done, I have a full image that I can download. So running parallel renderings, multiple large files being rendered at once and not taking up time on your own local computer that you could be designing other stuff, is a pretty awesome to have. And so if I pull open some of these renderings that were completed, we just have some different versions of the model here with maybe different environments or different materials added. Even if you're, picking between a few material choices or anything like that, you can just click Cloud Render, make some changes, click another Cloud Render. It's a pretty awesome tool. And along that line, in our last update, which was on the 30th of last month, we did get some really cool tools for rendering dielectrics. So I just want to pull open this image real quick. Dielectrics really just has to do with when you have transparent things that are seen through each other. So this model was fully created and rendered inside of Fusion 360. That is an awesome render. And I did it on the cloud. So, I got the model ready. I made a few changes. I submitted a cloud rendering. I found some stuff I didn't like. I made a few more changes, submitted another cloud rendering. So without having to wait on the computer to process those, this is a pretty awesome process. So I'm really excited about that. Check out our blog, our D3 Fusion blog. We're going to be having one coming up soon on that update. So if you're not familiar with our blog, d3tech.net is our website, and we've got a blog button right there on our main homepage. This is our Fusion blog, so we talk about features in Fusion. We let you guys know when there's updates. Here's a nice one on simulation. That model might look familiar. We'll even talk about all kinds of Fusion stuff in here. So if you're interested in that, check out our blog and look for an update on the rendering. It is a really great environment inside of Fusion. Obviously, there are more things that we didn't even cover in here. So We definitely encourage you to hit us up if you have any questions or would like to see more. Let us know. For today, that's about all I have. I want to thank you guys for your time. If nobody has any questions, have a great day.